702 and Cape Talk.
The Naked Scientist.
Chris, good morning and welcome to the Eusebius Makeza Show. Nicholas Bauer is my name.
Well, hello, Nicholas. Good morning.
Yeah, such a moment for me to tick one off my bucket list. I get to do a show with you, but I'll hold back my fanboy-ness for a moment or so. And I suppose we can start with news coming in the science realm from outer space. We've first of all got this Japanese spacecraft Hayabusa 2 attempting to collect a sample of rock from space. But how the hell are they going to do it if they're collecting it off an asteroid that's hurtling through the sky?
Oh, this is a really cool story. So in 2014, the Hayabusa, which is Japanese for Peregrine Falcon spacecraft, took off. And it's made a very long journey, but it's got to this asteroid, which is orbiting between the Earth and Mars. And that asteroid is called Ryugu. And last summer, as in British summer, so about June time, it caught up with the asteroid and has been in close proximity to it. And Hayabusa 2 has deployed a couple of small rovers. These haven't got wheels, they just land and make measurements onto the surface of the asteroid so they can measure some things about the surface. And now they're approaching more closely and they're going to do a series of sample capture experiments. So they're going to get some samples from the surface, and then later on, and this is the announcement this week, they're going to start doing this on the 22nd of February, and then later they're actually going to fire a projectile into the surface of the body and eject some material, and then get hopefully some pristine material from inside this asteroid. And then Hayabusa 2, the spacecraft, will use these sample collectors to sequester that material, and it will then begin the journey back to Earth. It will catch up with Earth's orbit by late 2020. And then as it goes past, it's going to dispatch these sample containers into Earth's atmosphere, which will arrive doing something like 12 kilometers a second. And they will then descend down through the atmosphere. And at the right height above the planet, they will deploy a parachute and ditch the heat shield that's been protecting them prior to that. And then they'll come down in Australia, hopefully, at a predefined landing site, and we should have some pristine samples from this asteroid, which orbits between Earth and Mars and is probably about 4.5 to 4.6 billion years old, and contains this material from which our whole solar system was put together. So it gives us an insight into the building blocks that the solar system formed from when it was young, about 4.6 billion years ago. Pretty amazing if they can pull this off.
Yeah, I mean, it certainly is something that I've never ever heard before. And it comes amid this, to my mind, a renewed interest in outer space and exploration there. I mean, not only do we have the European Space Agency announcing the launch of this so-called Rosalind Frank. It's going to be a Mars rover that's launched in 2020 and hopefully going to land on the red planet in 2021 in search of life. But we also had the Donald Trump in his State of the Union promising that American rockets are going to be going into space once again.
Yeah. Well, it's an exciting time. And the thing is that everyone says, why are we spending all this money trying to explore space when we have plenty of problems to solve here on Earth? But I'm a great supporter of trying to explore the universe, because not just because it's really interesting and trying to understand where we all came from is an important question, but also the other really important thing to bear in mind is that lots of the technology which is developed in order to surmount the problems of getting into space, because it's really tricky to get into space. It's really tricky to do the sorts of experiments that people are doing. It's really tricky to drive a robot round on the surface of Mars when it takes more time than it takes to make a cup of tea just for the message to get to Mars in the first place. And to solve those problems inevitably leads to solutions that solve problems back here on Earth. And some of the technology that we now take for granted here on our own planet was built in order to solve problems on other planets. Things like Wi-Fi was developed for radio astronomy so that they could collect data and pool all the data in one place easily. There are other things that were developed to make life on the International Space Station more bearable that we now use routinely here on Earth. So there are lots of examples of this. So I think these sorts of investments are really worth it because they teach us about where we came from. They teach us about the universe. They teach us about where we ultimately might want to go in the future. But they also do make life richer, both academically richer, but also more comfortable for everybody here on Earth.
Well, we wait to see what new developments come out of there, but we've got a long list of callers. Let's maybe start with Bokhosi and Kelvin. You want to talk about the Milky Way, Bokhosi?
Good morning, gentlemen. Yeah. Can the naked scientist
identify our location on the Milky Way? Are we on the edge of the Milky Way or towards the middle?
Hi, Bahorsi. So, first of all, a little bit of a sort of space anatomy lesson. So, the universe that we live in contains billions of galaxies, and the Milky Way is just one of them. We think there's something like a couple of 100 billion galaxies in the universe, and each of those galaxies contains hundreds of billions of stars, and they're pretty big. So the Milky Way galaxy, if I started flying from one side of it at the speed of light, or if I shone a laser beam from one side of it to the other, it would take 100,000 years for the light to get from one side of the galaxy to the other. So the Milky Way is huge. You ask about where we are in relation to it. Well, in the center of the Milky Way is a supermassive black hole, and orbiting around that black hole are stars, and those stars are stars including some stars like our sun, and orbiting around those stars are planets. We can see some of them now. Scientists have got systems to detect these so-called exoplanets. And if you ask, well, where are we in relation to them? By making measurements of how the stars that are in our galaxy are moving, we can therefore work out what our position in the Milky Way galaxy is. And the Milky Way looks like a swirl. So if you were to take a pen and start in the middle of a piece of paper and just draw a spiral going outwards, that's sort of roughly the shape of our galaxy. It's a flat disk, and we're on the outer edge of it. So luckily not in the middle where the black hole is. Don't want to go in there, but we're on one of the outer arms of that galaxy. And our galaxy is quite old. It's billions of years old. It's been here a long time.
Some might say it's a little bit young in comparison to other things, but that's a discussion for another day. If you just joined us, Naked Scientist Chris Smith on the line from the United Kingdom. And let's go to Claire in Fishhook. Claire, good morning.
Good morning, Chris. I wonder if you could just give me a brief, just an explanation of the North, the word, I've lost the word.
What, the North Pole, magnetic North?
Yeah, magnetic. Sorry, I just lost the word. Magnetic North Pole. And because it's rushing around at the moment, do you think that has any bearing on the extreme weather conditions we've got all over the place these days?
Hello, Claire. Now, when you say it's rushing around, do you mean the fact that the magnetic North Pole has moved a bit?
Well, I heard that it was moving rapidly at the moment.
Right, okay. First of all, what is the magnetic North Pole? Well, if we make measurements of planet Earth, we can see it has a magnetic field. And it's really important that the Earth has a magnetic field because that magnetic field extends out into space and it forms a sort of shield around our planet, so that when cosmic particles and the solar wind come rushing past the Earth, and they're doing about 1.5 to 2 million kilometers per hour as these particles surge past, they're deflected around the planet by the magnetic field. So we have our own sort of built-in shield. Where does that shield come from? Well, it comes from the core of the planet. The Earth's core is made of iron, and the inner core is solid iron, but around that solid inner core is a liquid iron core, which is in motion. It's turning. And for various reasons, and we only have theories about why, that mobile iron core is generating a magnetic field. And because of the orientation of the movements, it just so happens that at the moment, it's as though there's an enormous bar magnet inside the planet, and the south pole of that bar magnet is our North Pole, and the North Pole of that bar magnet is what we're calling the South Pole. Why is it the wrong way around? Well, that's because it's a convention when we use a compass. We're saying the compass points towards north. So it's arbitrary. But basically, we have a North Pole and a South Pole. Now, over time, over geological time, those poles have reversed. We haven't always had the North Pole where the North Pole is magnetically and the South Pole where the geographical South Pole is. It just so happens that's the way it is at the moment. How do we know it's changed? Because when the Earth's surface remodels itself through things like volcanism, so when you make new bits of seafloor, for example, and molten rocks come up from the Earth's interior, as they cool, they lock in the magnetic signature of the Earth as it is at that moment in time. So if we look at rocks from millions of years ago and we know how old those rocks are, and we look at where their magnetic field is pointing, we can work out what the Earth's magnetic field was doing at the time. Those measurements show us that the Earth's magnetic field has changed many, many times over the geological history of the planet, and it's done it on the scale of hundreds of thousands to million-year timescales. The last time there was a major flip round was about 800,000 years ago, I think. But it has happened many, many times, and it's happened many, many times while we've had life on Earth. So we know that those flips and changes in the Earth's magnetic field have not been sufficient to in any way hinder the progression of life or the evolution and development of life on Earth. So we don't think that the magnetic field is tightly bound up to what the Earth's climate's doing. The Earth's climate is more a function of how much energy is arriving from the sun and how good the Earth is at keeping that heat in the Earth system rather than reflecting it back off into space. And that's probably not related to what the magnetic field is doing.
All right, Claire, I hope that answers your question. Claire and Fishhook, we're talking to the Naked Scientist, and a very pertinent and relevant caller now, Abram, who is driving. I hope you're on a hands-free, Abram, but you want to ask something about words?
Yeah, I am on what's name. You should have forgotten the word again. Well, the lady that just called in said you should forget words. I forget words. I remember things from way back then, but I forget things, words, stupid words.
All right, Abram, let's keep it short and sharp. Let's see if Chris can answer us there. Why do people forget words? Why do you think of a word? It's on the tip of your tongue, but you're just
and it's gone. I know. Happens to all of us. And everyone thinks, oh my goodness, am I going mad, or have I got dementia or something? But it's very, very common. It happens to everybody every day. And if you think about it, the process of speech is an incredibly demanding thing to do. Your brain has got to work very fast. It's got to interpret information. It's then got to plan out what it's going to say next, select all the right words, and then execute the right movements of your lungs, your throat, your vocal cords, your face, your mouth, tongue, in order to make the right sounds, to make the words in the right order. And while all that's going on, it's got to be doing it at the right volume. It's got to be listening to make sure that you're making sense to yourself and planning what you're going to say next, and also watching the reaction of the person you're talking to make sure that they seem to be getting it, so that you know that you're choosing your words the right way. So it's a really cognitively demanding process. And anything that interrupts that or distracts you, or anything that can in any way frustrate the process, throws a spanner in the works. And because that process is so demanding, every so often you just get a mental block. And the thing about a lost word is not to obsess about the word you've forgotten, because it's a little bit like when you go to a library and you know you want a certain book in the library. In the old days, the way you'd find a book in the library is you go to the index cards, and there'd be drawers full of all these cards, and they would tell you where on the shelf to go and get a certain book. Well, when your brain wants a certain word, it goes to the index file and it says, right, where on the shelf is that word? And it then goes to the right shelf to get the word. Well, occasionally it's like someone naughty has borrowed a book and not put it back on the shelf. So the brain goes for that word. It can't find it. If you're not careful and you obsess about it too much, you will learn where the book isn't. So you'll learn that you don't know the word, rather than if you just relax, forget it, move on. About 30 seconds to 5 minutes later, the word you were looking for will pop into your head, and then you won't forget it again. So be reassured, it's completely normal. It happens to everybody. It should only be a cause for alarm if it suddenly starts to happen to you a lot more, and then maybe you should get things checked out. But if it's something you've always done, it hasn't changed dramatically, just regard yourself as normal.
All right, we've got a voice note we'll play next after Angelo. Angelo, you want to talk about lunar cycles?
Yes. Hi, gentlemen. I just wanted to ask a question, and I've only ever seen it maybe twice or three times in my whole life. Is sometimes the moon looks really, really, really large in the sky. It's usually on the horizon, and it almost seems as if you could basically, it's like 4 or 5 times its normal size. I'd just like to know what that phenomenon is, because a lot of the times you've heard it's something to do with where it is in the sky, but it just doesn't seem to make sense to me as to why the moon would look so big and so close, like only a few times a decade.
Yeah, hi, Angelo. There's a number of factors here, but the most prominent one is the one that the psychologists actually call the moon on the horizon phenomenon. And the brain works out how big to make things look by comparing things in the visual scene to each other. When the moon is in the top of the sky, so high up in the sky, the only thing you're seeing is the moon, and you've nothing else to compare it with. But when the moon is on the horizon, you see other objects in the same context. So you may see trees and buildings and then the moon. And the brain knows that those buildings are quite close to you. And it assumes, therefore, that the moon is also quite close to you. But we know the moon is a long way away, so the brain artificially inflates the size of the moon to make it look bigger. This is the thinking, that it's an optical illusion because you see things on the ground in the same context as the moon, but the moon seen in isolation later looks much smaller. The reality is that when you're seeing the moon on the horizon, of course, it's actually the light from the moon is passing through a lot more atmosphere to get to you than when the moon is high up in the sky. So actually, it's just an optical illusion. There are some other issues about how the moon's lit, in what positions, in what phase of its cycle, and when we tend to see it. So you do sometimes see these so-called supermoon phenomena as well. But the most common thing that people describe is the one I've said to you, which is that the moon seen in the context of other things much closer to you give the brain the impression it must be much bigger than it is. So it artificially makes it look bigger to you.
Morning, Nicholas. This is Jack from Alberton. I just want to find out, how does a fat form in the stomach, and what is the usefulness of a fat? Can it also maybe be harvested to be used, maybe to power one bulb? Does it, in actual fact, have any usefulness? Thanks. Bye.
Interesting voice note there, Chris. And I mean, are some farts more equal than others in terms of potential power?
Oh, we've lowered the tone here, haven't we? Okay. Actually, we haven't had a fart question for a while, so this is quite timely. The answer to this question is that everybody does it, so no one can pretend that they don't, and the average person does it 10 to 20 times a day, and the average volume released from the body is a litre or so, half a litre to a litre of fart gas per day. The origin of most farts comes from two places. One, when we eat, we swallow a bit of air, and some of it makes its way down our digestive tract. Most of the gas, though, comes from the inhabitants of our intestines that are not us, in other words, microorganisms. And when bacteria, which are largely and most commonly present in the large intestine, when they see products of digestion that we can't digest, they can digest those things and they turn them into breakdown products. And these include some chemicals, some things that dissolve, but they also make gas. For instance, when you eat things that you can't break down, things with a lot of fiber in them, cellulose is the medical word for fiber. This is plant material. It's very good because it binds a lot of water, so it keeps your bowels active. Bacteria do have enzymes that can break that cellulose down. And when they do so, they make a lot of carbon dioxide. Some classes of microorganisms, because there's not much oxygen in the intestine, they thrive in this anaerobic environment and they make things like methane. And there are also bacteria and enzymes in there that can produce smellier compounds, because methane's odorless. They can produce hydrogen sulfides and also methyl mercaptan, which is the same chemical that a skunk makes. And these chemicals are all present in small amounts, and they build up in pockets of gas in the intestine. And then as everything moves along, the pockets of gas coalesce to make bigger pockets of gas, and eventually they make it down to the bottom end. And hopefully at a time that's socially acceptable, we release the gas so that it doesn't painfully stretch the intestine, because the distension that you feel, sometimes you think, well, I feel a bit kind of gassy. This is because your intestines are very sensitive to being stretched. And these pockets of gas do cause local stretch and dilatation, and that makes you have the urge to go to the lavatory. But you can also tell through very dense nerves at the bottom end the difference, hopefully, between solid material and gaseous material. And you can tell when you can squeeze and release, and other times when you shouldn't. And that's what we do to get rid of it. In terms of whether it's useful or not, no, it's not terribly useful, because the amount is very small. It would be impractical to collect it. It's a mixture of gases, not a pure set of gases. There's a bit of hydrogen and methane in there, so it can be flammable. I wouldn't advise setting fire to it. You might hurt yourself. And if you're a big animal like a cow or a kangaroo or other ruminant animals like sheep and goats and things, they actually belch out enormous amounts of methane from the bacteria that live in their stomach, and they're very bad for the environment because they're contributing to the greenhouse effect. So farts and burps are not necessarily good for the environment in more ways than one.
Oh, one wonders whether or not that'll change in years to come. Let's try and squeeze in another one. Brad and Sea Point, please keep it brief, to the point. Ask Chris your question.
Yeah, hi. It's a question to say to you personally. Do you believe in God or a God? And if so, what is that God?
Interesting scientific take there, Chris.
Yeah. To be honest, myself, I'm not religious, but I have not ever come across anything in my scientific career that is at odds with religion. because people always see this tension between religion and science, and actually I don't think there is one. We know that the universe began in a Big Bang about 13.8 billion years ago. Well, who's not to say that wasn't the day of creation? We know that the planet has all these rules of evolution, and people say, well, evolution and religion are not compatible. Well, actually, if God wanted a planet that was going to work in harmony and in sync the way it does, then the best thing to do is to set some rules of nature by which everything would evolve, because that way everything's going to work in sync together. So I think the process of evolution and natural selection is entirely compatible with there being a God, because a sensible God would put those rules in place. So I've not come across anything that scientifically that's at odds with religion. What I do think, though, is that we should keep religious education in the religious classroom, and we should keep scientific education in the scientific classroom. That scientists should not go into religious lessons and tell people how to be religious, and vice versa, because the two things are quite different phenomena.
Sheesh. Are you sure you're not a diplomat in your spare time there? Because you just walked a tightrope of razor blades across a question I don't think I would be able to answer, Chris.
Well, it's important, because the thing is, religion is important to millions and millions of people around the world, and they have their beliefs, and they're perfectly entitled to. And it's very likely that we have evolved, and we're successful as a species because we have evolved to have these sorts of thoughts and feelings and perhaps religious convictions. At the same time, it's important to exercise scientific approaches to things, because that means you test things and you use evidence to inform them. But that's not to say that you can't be both religious and scientific. It's just that the two things are quite different. One of them is a human function. One of them is something that applies wherever you go in the universe. They're not one and the same, and we shouldn't argue one and the same. They're two totally different things.
702 and Cape Talk. The Naked Scientist.
Yeah, we've got Chris for a couple of more minutes. We'll have to keep it short and sharp. Thanks for the time, Chris. We've got Mabel in Attridgeville. She's been patiently waiting. You want to talk about CCTV, Mabel?
Hi, Nick. Hi, Chris. I've got a CCTV screen next to my bed. I wanted to know whether it has an harmful effect on my body.
If I may just add a caveat as well, I mean, could you include in your answer whether or not there's anything overtly harmful from having cell phones slapped to our ears for every waking hour of the day?
Oh, that's quite a different question. But first of all, Mabel, your question about CCTV screen, there are a couple of aspects to this. I presume, or I'm going to assume, it's probably an LCD flat screen. And the thing about flat screens that we've realized in recent years is that because the screen is lit by white light, that white light is made by blue LEDs, which pass through a chemical called a phosphor that makes white light. That means the light that comes through these screens tends to be very blue dominated. And the back of the eye contains a sheet of cells, the retina, some of which are very sensitive to blue light and are used to control your body clock. So if you stare at LCD screens, including telephones, mobile phones, smartphones, laptops, your home television, late into the evening, you could be sending a signal into your brain that says, wake up, it's morning. And this can lead to A, going to bed later, B, not sleeping so quickly, and C, not sleeping so well. So you could potentially be disturbing your sleep by having a screen that's illuminated and drenching you in this blue light before you go to bed. So you might want to think about whether or not that screen is on or off, and at what time of the evening you actually look at it. Now, Nick's question about mobile phones, this is quite different, because unlike a screen which is emitting light you can see, a mobile phone is emitting light that you can't see. This is electromagnetic radiation in the form of the microwave signals that the phone uses in order to send signals back and forth to its base station. These are roughly the same sort of signals that you use when you cook food in your microwave oven or Wi-Fi and so on. We use that wavelength because we believe this wavelength of light is not harmful. There's no evidence when you actually deluge cells in this that it has the energy to damage the DNA in the cells, so we don't think it could be linked to cancer. It can cause a heating effect, though, and so it's not impossible that being exposed to these could produce biochemical effects in tissues in response to heat and the exposure to the microwaves hitting other things. But there's no evidence that they could, for instance, at the moment, be linked to cancer. And the evidence that we have for this is that people know how many mobile phones there are in circulation around the world. We have really good data, because companies are billing people for their use, of how much people are being exposed to mobile phone use. And we also have people tracking whether or not we're seeing an increasing rates of cancer, particularly brain cancers, for example. Now, if mobile phones were causing cancer, and that means a very specific thing, the word cause, then what we should see is that with increasing exposure to a phone, you should see an increase in rate of cancers occurring. And at the moment, we're not seeing a big increase in rates of cancers, but we are seeing a big increase in rates of phone use. So this tells us at the moment that, at least in the timescale we've been looking, there isn't any evidence that these phone infrastructures and mobile phone use is linked to the cancers that we're looking for. That may change as more data are acquired and as time goes on, but for the moment we're comfortable that they're not doing us harm if used sensibly, and you're not actually harming yourself psychologically by continuously staring at a screen and being glued to social media.
Well, thanks very much for that one, Chris. We got one more question in here, and then I've got a Valentine's question of my own related to flowers and chocolate. Karen in Cape Town, though, you want to talk about science not really meaning anything at all.
Hi there. Yes, all this research, and we talk about scientists and research, and I'm just wondering if there's been any research done into the redundancy of discovery. People having more and more, getting bigger cars, bigger houses, better clothes, fancier appliances. I wonder if there has been any studies done into when this will reach a point at which enough people say, we don't need to discover anything anymore. We've got it all. Boom.
Well, I think you're assuming that the trappings of modern life are directly paralleled with on a direct consequence of doing science. And to a certain extent, a lot of the wonderful things we have in the world and wonderful treatments for diseases and the foods we eat and so on are because of science. That's certainly true, but they're not the same. The quality of life we enjoy is not directly proportional to what we discover in science. For instance, knowing whether or not there was life on Mars probably isn't going to make my life anything other than academically richer here on Earth, at least in the short term. So I do think that scientific endeavor and understanding the universe and understanding how things work, that is important, and that will go on because we're never going to understand everything, with the best will in the world. We're not. But at the same time, there's no harm in using the learning from that to improve life on Earth. But I think the Earth has a lot of bigger problems that it needs to solve in the short term, such as the population problem. There are far too many humans on this planet now, and we are having to use science in order to keep ourselves all alive. We wouldn't be able to feed everyone on the planet if it weren't for the fact that people had invented fertilizer. And if we didn't have the way of making ammonia developed about 100 years ago, we wouldn't be able to make fertilizer, and we would have a lot of hungry people. We wouldn't have the population we do. So I think we do owe a lot to science for our modern living, but that's again a slightly different dichotomous argument, because science for science's sake is quite different than science that's applied to make life better.
Well, thanks very much for that one, Karen. And a parting shot from me then. I've been saving this one up, Chris, and you may have no scientific explanation for it, but let me give it a go. Valentine's Day next week, Thursday. And any scientific explanation as to why flowers and chocolate have made it front and center in terms of gifts to give to your significant other on the 14th of February? Anything to do with sensory perception, the way chocolate makes you feel, or I don't know, the way your senses react to the smell of freshly cut flowers?
Yeah, there's a range of different things that play into this. The chocolate angle. Chocolate is historically quite expensive, and it was a luxury item. So it earned itself a place as this is a gift to give if you really want to impress someone. And the fact that it tastes nice and also contains various chemicals that make you feel good, because there are various neuroactive chemicals in chocolate which do make you feel quite good. That probably is why it won a place in the hearts of everybody, men and women. Flowers, a bit similar in some respects, because although we take cut flowers and that kind of thing for granted today, historically it was much harder to get flowers and to get a whole range of these exotic blooms and things unless you were very rich and you had the resources to do so. And so being able to access those sorts of resources meant that you were clearly someone who cared a lot about the other person, because you were going to extraordinary lengths, both financial and physical, to get these things for them. And that was a way of showing someone that you really cared about them. And I think that sort of caught on. And as a result, we've turned the whole industry around that. And we haven't come up with anything better to give instead. Although I think if you ask lots of people, they'd say, well, given a choice, bunch of flowers or a car, I'd have the car, actually. But I don't mind the odd bunch of flowers.
If only that was common on Valentine's Day. I mean, are you one of those lucky people that have received a card at some point in time in your life, Chris?
Well, luckily, I got my wife thanks to a Valentine's Day card. So I'm a very firm believer. I sent her one, she sent me one, but we'd never really actually spoken very much to each other before we did that. We just knew we liked each other. So I'm very grateful to Valentine's Day because I actually got an amazing wife out of it. So I'm a big believer.
Fantastic. Maybe the most scientific, non-scientific story you've ever said. Chris, have a fantastic weekend. Thanks for joining us.
Thanks, everybody. Bye-bye.